Good afternoon to all of you and welcome you for another session in GVA Talk Talks. Let me introduce myself. I'm Dinooli. Today I'm going to talk about expert systems. Let me move on. These are the main topics that I'm going to discuss. Let me explain in the as we move on. And what are expert systems? As you all know, in artificial intelligence, there are two broad categories. Expert systems comes under cognitive systems. We can find many definitions for expert systems in many websites, Wikipedia, and many places. And these are some. But I would say it is simply a high-level intelligent programs that is used to mimic the intelligent behavior of a human mind, which performs complex problem-solving behavior of human experts. So, as I told you before, there are two broad categories in artificial intelligence, which is one is the human brain is capable of learning theories and apply them for practical problem solving. That comes under cognitive systems, which is theoretical learning abilities, functions of human brain. And the other one comes as training abilities, where you do not learn any theories, but you practice on several number of examples and gain that practice and apply that knowledge on practical problem solving. That comes under machine learning systems. AI was initially developed in late 19th century, and from then onwards, these two fields come in total different directions. So there are cognitive functions of brain, as you think. You can perceive things, think, learn, reasoning out, decision and analyzing. Those are the basic functions of human brain that could mimic by cognitive systems. So we can conclude that expert systems are as cognitive systems that solve problem by theoretical manipulations. We can compare an expert system by comparing to a medical doctor. Let's say when you go to a doctor initially, what did the doctor ask you? Doctor asked you why you have come. So he predominantly asked the questions from you. So he asks what's your disease or what's your symptom. So what is expertise? Asking more questions than the client. And a expert can work on incomplete information. So when you go to doctor and say you have vomiting and fever, but doctor may know there can be another symptoms. So doctor tries to form some conflict sets and think about what are the possible diseases that this person has. And then heuristics and experiences. Doctors usually come to decisions with his past experience. Heuristics is kind of that telling you that you're going to have some kind of conclusion or problem solving strategy based on your previous experiences. So expert systems are such, so they're going to use heuristics and experiences as well as medical doctors or experts in some kind of a domain, and provide not only solutions but also reasons for solutions if required. If you ask from your doctor, what is the disease I have? So what is the condition I have? So doctor can explain if you want. If you want more information, you can really ask from the doctor, so he can explain because he has the expertise knowledge on that particular field. And doctor can give you more than one solutions or alternatives. Expert systems are such because let me take one example. If I say to a doctor, I am allergic to a particular medicine called Ventolin, so doctor may prescribe me an alternative like some Piriton or someone else. As that expert systems can have that can give you alternate solutions, like more than one solutions. And expert systems are really useful in a domain or any application where you have not only a exact solution but maybe a range of solutions. So he can propose you, recommend you a couple of solutions, and able to provide a level of assurance, certainty or validity of a given solution. Doctor may say, if you get this medical, so you will be get cured by 100%. But if you take this medicine, you won't be cured by that much. But if you take many rest and if you follow my instructions, you will be cured in this time. So as that, he can be certain or assure what his solutions are, and provide recommendations than exact answers. As I told you before, expert systems are more suitable for a domain where you don't have exact answers. If you have exact answers, yes, you could simply use a database system and query and get the exact answers. But not here. Expert systems, you can provide recommendations. Doctor always don't tell you have to do this, but he gives recommendations, and operate on specific known area of knowledge. And let's say a medical doctor, he's specialized in cardiovascular diseases. He can't work on neurological. So expert is specialized and his knowledge is narrowed on a particular domain, and he doesn't have any other idea. Expert is knowledge on other fields at the same time. So when you develop an expert system, that expert system particularly work on that specific domain. You can't use that in another completely different domain. And forms a conflict set and does the conflict resolution. I'm going to discuss that in the next slide. That is how the expert system works. When you go to a doctor and initially say you have these symptoms like fever and vomiting, doctor thinks about what could be the possible diseases that you may have. So by his knowledge and experiences, he would think you have these three diseases. That is called the conflict set. For these three diseases, you may have this base common symptoms as vomiting and fever. What doctor does is ask you more questions to clarify and confirm what your disease is. So he start one by one and ask you whether you have loss of appetite. So if not, so he will go to the next one. If yes, so he can conclude that you have an infection. If not, so one by one he goes. If you reach the end of the list, so he can't say which disease you exactly have. So at that moment, expert system can't give you exact answer. So that is the normal process what expert system does, same as a medical doctor. This process is called conflict resolution by asking many questions. Moving on, this is the basic architectural components of expert systems. If you take many high-level systems and comprehensive systems, other than these three main components, there are components for explaining, reasoning out, analyzing, maybe some machine learning or deep learning facilities. But for any basic expert system, these are the essential components. I'll go into details. User interface. Normally in expert systems, they have very comprehensive interfaces. User interface is the method by which the expert systems interact with the user. User is there is a non-expert. So there can be dialog boxes, prompts, command prompts, forms or other form of inputs, maybe natural language capabilities as well, to get information from the user and interact with the user. So some expert systems directly do not interact with human, or they may interact with another applications, third-party applications or another computer systems. So the intermediate communication medium should be compatible for those two devices or systems. And there are facilities for asking questions, displaying your result in a comprehensive manner that could understand by the user, and capturing missing information. As I told you before, that let's say you tell a doctor about particular symptoms, but when the doctors look at you, the doctor says your eyes are ready. So that's or your swelling. So that information should be captured. If it's not, so that means the expert can work on incomplete information if the interface can capture those missing informations. And most of the high-level interfaces have natural language processes and multimedia features. I have seen some examples that they use for skin cancers and skin rashes. They use the pictures of them to analyze those diseases. And user informations allow you to access web resources if needed as well. And this is the most crucial part in the expert system, the inference engine, which is kind of a core processor of the system. This is the component that applies logic rules, which is in the knowledge base, to deduce new information out of the rules and the facts that you gain from the user. Expert systems, its inference engine runs the systems and determines which rule to be applied and executing the rules to determine which is the acceptable solution and determine what is the acceptable solution and when is the time to get the acceptable solution. And inference engines mainly work on one of these two modes, backward chaining and forward chaining. If I tell you about this, let's say you come to a house after a long journey and you see your house being robbed. So if you go in the backward chaining directions, it is saying you start with known facts and conditions, assert new facts, and see which conclusion you can be made. That is, you don't know from where that thief is entered your house. So you check which the window is broken, which door is open. So you find what are the details and you get some facts and you conclude the decision and go to a decision like that. So the other way around is backward chaining. You decide, you know the weakest point of your house, that could be the back door. So thief must have been broken from there, and you know the decision, and you find the facts whether it's true or not. You can form that conclusion or not. So backward chaining is the other way around. If you can see from this diagram, forward chaining, you have facts, you get decisions, and if you have more facts, you can improve your decision and come to the final decision at the end. And the backward chaining is the other way around. Knowledge base. Knowledge base is one of the most important part in the expert system, other than the inference engine. Knowledge base, if you have a correct, enriched data, accurate data, so your expert system's accuracy and quality of result is high. So there are many types of knowledge, as you know. There can be static knowledge, dynamic knowledge, or heuristic knowledge you gain by your experiences, and procedural knowledge and declaratory knowledge. But there are four main techniques that you could represent these knowledges. Out of these four techniques, most of the expert systems use this rule-based representation technique, where there are other techniques as well, logical representation, BOUs, propositional logic and predicate logics, and network representations by graphical entities. Graphically by entities. Entities are such like attributes and nodes are like values. There is one expert system framework that I found, like ES Filter. They provide you to build expert systems with network representation, where you don't have to have zero knowledge of expert system or any programming. What you have to do is build your decision tree and build your nodes and attributes. So you can have a simple expert system, and you can do it online as well. And structured representation is something like objects and frames. They have their own properties, and you connect those ontologies with those properties and make relations, so you can have a like comprehensive knowledge network from that. As I've said you, rule-based representation is in the rule sign if-then form. Let's say as simply, this is the most popular for the expert systems. It is simple as that: if the sun is shining, then the rules are in this form. I'll go into this is expert systems shells. This is kind of a framework that you use to develop expert systems. These are like high level ones. For high levels are really expensive, and you need to get a license to use these ones. And there are like primary ones as well. Expert system shell is by definition is a piece of software that contains facilities to develop commercially and practically viable expert systems. And these are kind of ready-made expert systems, but without the knowledge base. What you have to do is fill your knowledge base with relevant facts and rules. And expert systems have built-in tools to develop high-level interactive interfaces and inference models, and structuring your knowledge base as per the previous told representation techniques. And in high-level systems, you have additional features such as extension of UI with web interfaces, third-party applications or mobile applications, and extension of a knowledge base with external databases, file servers, web servers, and provide web connectivity or system if needed, and plugins for inference engines like FOSSI modules, logic modules, and most importantly, they have the natural language processing features that you can input text and voice, and you can analyze them as well. And these expert systems are really expensive and very comprehensive. You need to have very comprehensive and fluency in those domains to use them. But there are like simple ones with base languages like Java, C++, and very comprehensive specific languages like Prolog and Lisp. You can use with less efforts just Java expert system shell and Clips, but for other ones you need to have a comprehensive knowledge like Drools, Crystals, Leonardo, and Flex. If I talk about the applications of these expert systems, they are mostly used in late 90s and early of 20th century, but I'll tell you in forward. As we move on, there are practical applications and most developed applications as now. And for all of these domains, if you have any, repetitive problems happening, when you need expertise knowledge, and human expertise knowledge is very expensive. You have to hire experts every time. So if you have an expert system in these domains, you can make it done very easily and efficiently with less cost. And I'll go into one solution like for loan analysis. In that domain, when you have customers for a particular branch, you have to analyze whether this customer is suitable for applying a loan. What is his grant, and what is the payment period, so whether he have satisfied the base conditions and constraints to apply for a loan. So as that, there are plenty of application domains in this expert system industry. I'll move on. I'll talk about some most famous expert system. Dendral is the world's first expert system developed by Carnegie Mellon University, which is to analyze chemical compounds to predict their molecular structure. And DART, this is a very special one used by DARPA, you know about that American military agency. For that logistic planning system, it was a logistic planning system for entire Gulf War. And at that period, where that AI applications are mostly played in, and they are practically used. Mycin is another medical application which identifies bacteria causing acute infections, and it can prescribe drugs based on the patient's weight. And PhD is express system is to predict degree and type of lung cancers, and there are many other applications and famous systems. You can find it from this you can see from here. You can see how this expert systems works, and there are some other details. If I show you, this is the way that expert systems ask questions from the user. So by this questions, at the end of these questions, he come to a conclusion. I'll show my demo with the prologue, which is this is regarding a lung disease diagnosis system, which I have used the code. You can simply download this prologue application, and you can write this code in any text editor like Notepad or anything. I'll just open this code from this editor. After you're writing the code, you can you have to place this in documents prologue file, and you can simply consult it, and that means that it's compiling. You can simply start it. So this is the interface. I'll describe you a little bit about the code. I have used a single file. Here you can see the knowledge base, user interface, and inference engine at one single place. This kind of predicate is initially for welcoming the system, and these are the actual predicates. These are the rules in knowledge base. So this hypothesis part up until to here, these are the rules. So I'll explain one rule. This disease predicate is about a patient. If you have influenza, you should have these symptoms. Like the other way around, if you have these symptoms all, so it can conclude that you have this disease, influenza. As such, this is the inference engine part. So for asking questions, you have to define what predicate that you are going to ask custom. So the question I am basing on whether this person have this symptom or not. So the ask predicate does that prompt the user with this question and get his confirmation or denial about the answer of this symptom. And I told you that expert systems keep track of and remembers his experiences, and this is something similar to what is happening here with this known predicate. It has 3 parameters. From what you ask, he can remember your answer. He keep remembering answer. This is happening with this known predicate, and this is the UI part. So you ask the question and write the question and the this symptom, and you make it easier for the user to answer whether it's yes or no, and read the answer and assert it whether the answer is true or false or yes or not. And this is the part you assert is true or false. And these are the predicates for results. And when you diagnose a disease, it's like loading, and finally you get the symptom and the disease repetitively and see whether you can conclude this disease, and this is the final outcome. If you can't find it, so this is the predicate that you use to tell them. And here, this is the start. This is actually starting executing command of this code, and this is notice is the initial predicate that I used to welcome the system, and here you have to repeat what this process is up until you come to a conclusion. And this abolition dynamic isn't that in a single instance you can run several diagnosing processes after one is finished. So this abolish is telling that at the runtime this known can be dynamically changed, and diagnose is the one with doing the results. And finally, if you want to try again, so you can run this diagnosis process several times. If at the end you get this last lines as this, and I'll show you running this. First let me point on to some disease. Let's say pneumonia. I'll take an easy one. Pneumonia. So about how expert systems run this, is basically going in the order as it is declared in. So it first look at whether you have tuberculosis. If one symptom is fails, it goes to another one. So as that it goes to at the end of the system. And let's see one. You can simply say yes or y dot. Let's say since I don't have persistent carpet pneumonia symptoms, so I'll say no. And you can say that since I said no, so any other asking for another sentence is useless. So prolog directly goes to the second one. If I say yes to dry cough, and you can see the next one is asked directly fever. If I say yes, if I say yes and go forward, you can see the third one is asking for chills. Yes. And short of the bit, the last one. So you can conclude that you have pneumonia. So if I'm trying again, yes. Let's see, I have a combination of symptoms where you don't have any conclusion at all. So I'll randomly say something. It keeps asking questions until the end of the rules. Yeah. So it keeps remember. So if you have one disease, let's say you have one disease with one symptoms, and that symptoms is applied for another disease as well. So he keeps track on it. If you have, like say for the second disease, if you have another symptoms failed, so it doesn't ask for that. So it goes to the next one. So as you see, you can't come to a conclusion. If you run it several times, you can see how this works, but I'll show you some other thing. Let me move on to this lung cancer. So this lack of appetite is appearing at the first one as well. So if you fail it from the beginning, yes, you have dry cough, yes, you have fever, shaking chills, no. Chest tightness, no. Runny nose, no. Chronic cough, no. Shortness of breath, no. Wheezing, yes. And cough, no. Oops, I'm sorry, I made a mistake there. Let's consult again. So here I'm pointing at this lung cancer. Fever, yes. Shaking chills, no. Tightness, no. Runny nose, no. Chronic cough, no. Shortness of breath, no. Yes, we have the shortness of breath at the last point. Chest pain, yes. And scaly rash, no. And wheezing, yes. Cough, no. You have dry cough but not normal cough. Blue skin, no. And headache, yes. Hoarseness, yes. Chest pain, yes. So you can see the next question is weight loss, and if you go furthermore, you can see the lack of appetite, cough in blood, headache, and shortness of breath. It's coming at a time. If I say yes. No, if I say persistent cough, okay, but the second one is failing, so you don't get that. So you go into the bottom one as well. So you can see after weight loss, you have the lack of appetite, and then probably the next one could be the coughing blood. Yes. And to conclude that, you have lung cancer. These are the expert system basically work, but in here I have like 10 rules, but in complex systems you have more than 100 to 150 rules. That is the like normal range for well performing expert system. If I go to my screen, I'll show you a small video clip. Oops. Yeah. This is one of the modern applications in medical domain. is one of the modern application. As I said you previously, in late early 90s, the expert systems and machine learning systems walked in two separate directions. But as the time passes, you identified many limitations for all these systems, and you try to combine all this together. And for the modern researches are going on for combining these two fields, machine learning training abilities and cognitive abilities in one system. There are researchers and there are corporations that are producing products regarding that. This research paper suggests you about something like that, where neural network is used on expert system. So it's one of the modern application, and you can see this applications in this website, where the corporation is Cogito, and they have many advanced applications. I have this is research paper talking about the advancements of these researches, and what they have concluded is, if you can see, while all having their advantages, the approach using a neural network has proven to be the most effective and efficient way of developing durable and reliable expert systems that would not become obsolete over time. Because the earlier expert systems that I have told you in those examples are kind of obsolete by the time now, and these solutions you can use it for more decades until you find another solutions, more effective solutions. And as for the completion, I'll talk about a little bit of advantages. And as I said, hiring experts, human experts, is really expensive. If you can have aware of the cost of having an expert system, so you can have that advantage at low cost, and provides fast and efficient solutions for a problem in a narrow and specific domain. And I'll go into more specific ones. Yeah, the other one is if you use a human expert, if you get the service from a human expert, so he may feel fatigue, monotony, and tiresome. So that kind of problem is not there with the expert systems, and you can have the knowledge of several experts at the same time. So if you talk in reality, if you hire many experts, so you have to bear a lot of cost, and so. But with an expert system, you can have this all the knowledge at one place, and your results are more enriched with all those knowledge as well. And limitations. These limitations have been overcome in modern examples that I have shown you. It's really not suitable for time-critical applications. For time-critical applications, you use machine learning systems, because expert systems take time for reasoning, for finding alternative solutions, and it takes really time. But machine learning systems are different from that. You can have very fast solutions, and there's a problem with this expert systems where you can't feed in human intuition and common sense to your signals, and you can't have your tacit knowledge. There are two types of knowledge, the implicit knowledge and explicit knowledge. Explicit knowledge, yes, you can have it in your books and write it somewhere, and you can transfer them. But tacit knowledge or implicit knowledge, you can't do that. So you can't fed that expertise, tacit knowledge to expert systems, and these solutions are lack of intuition. So that sometimes in some domains these systems are not applicable because of that reason. So as human, we have to think by heart sometimes, think by brain sometimes. So that there is a difference between that. So expert systems are sometimes it's not applicable for some domains because of that. And human self-awareness that is lacking in expert systems. And yes, you may adhere to all the rules, but sometimes there are situations that you have to overcome those and go by your heart or by your self-awareness. That is lacking in expert systems. And as I told you before, that tacit knowledge, knowledge engineers can't fully tackle that tacit knowledge and in particular domains. And if one expert system is developed for a particular application, you can't use it for any other, because that rule engine, the knowledge base is specifically designed for that particular case. So you can't use it for another application. So you have to develop it from the scratch for another application. These are the basic limitations and advantages, but most of the other limitations have been overcome by the modern systems. So that is the end of my presentations. If you have any questions, I will. Seems you not. Okay, I may finish it. And thank you for listening.